On July 4, 2012, the human race declared victory over the physical world. Deep beneath the border of France and Switzerland, inside the 27-kilometer ring of the Large Hadron Collider, we found it. The Higgs Boson. The media called it the God particle. It was the final piece of the Standard Model puzzle. It was the proof that we understood the fundamental architecture of reality. Physicists wept. Nobel Prizes were awarded. The world celebrated the idea that the universe was a solved equation. But they were wrong. The champagne was premature. Because while the public saw a trophy, the theoretical physicists saw a warning sign. Buried in the petabytes of collision data, hiding behind the applause, was a specific number. A mass measurement that didn't just complete the Standard Model, it broke it. 125.35 gigaelectronvolts. This is the mass of the Higgs boson. To you, it is just a number. To a quantum physicist, it is the most terrifying coordinate in the universe. You see, the mass of the Higgs determines the stability of the vacuum of space itself. If the Higgs were heavier, say 140 GeV, the universe would be completely stable. The laws of physics would be set in stone, eternal and unchanging. If the Higgs were lighter, below 120 GeV, the universe would be unstable. It would have collapsed back in on itself moments after the Big Bang. You wouldn't be here to watch this video. But nature didn't choose stability. And it didn't choose immediate collapse. It chose 125 GeV. It chose the razor's edge. This specific mass places our universe in a state known as metastability. Metastable is a polite scientific term for a ticking time bomb. It means that the universe we live in, the stars, the galaxies, the atoms in your blood, is not the true version of reality. We are living in a false vacuum. Think of the universe as a frozen lake. For 13.8 billion years, we have been walking on the ice. We built our civilizations on it. We assumed the ice was the solid ground. We assumed the ice was the bottom. But the data from CERN suggests that the water underneath is deep. And the ice is much, much thinner than we thought. The true vacuum lies below us, a state of lower energy, different physics, and total silence. The ice has held our weight for billions of years, giving us the illusion of safety. But probability does not care about time. It only cares about potential. And right now, every cubic centimeter of empty space in the cosmos is under tension. It is waiting for a kick. It is waiting for a trigger. We are not living on solid ground. We are living on a trapdoor. And on July 4, 2012, we didn't just find the God particle. We found the latch. To understand why the floor might drop out from under us, we have to look at the foundation. Forget atoms. Forget quarks. We need to talk about fields. The universe is not empty space with particles floating in it. It is an ocean of energy fields. The most important of these is the Higgs field. Think of the Higgs field as a thick, invisible fluid that permeates every single inch of the cosmos. It is everywhere. Inside your body, inside the Earth, and in the deepest void between galaxies. This field is what gives particles their mass. Without it, electrons would fly around at the speed of light, unable to bond with protons. Atoms couldn't form. You couldn't exist. For the universe to be safe, this field needs to be in its lowest possible energy state. It needs to be calm, silent. In physics, everything seeks the lowest energy state. A ball rolls down a hill until it hits the bottom. Once it's there, it stays there. That is stability. That is a true vacuum. If our universe were a true vacuum, the Higgs field would be that ball at the bottom of the valley. Nothing could move it. We would be safe forever. But the math tells a different story. We are not at the bottom. We are here. We are stuck in a little dip, high up on the slope. This is the false vacuum. To the naked eye, the ball looks stable. It isn't rolling. It has stayed in that little dip for 13.8 billion years. But just over the ridge, separated by a thin wall of energy, is the drop. A drop into a deeper valley. A state of much lower energy. The potential energy stored in our vacuum is like a dam holding back an ocean. It feels solid, but the pressure is immense. And the water wants to get out. This isn't just a scary analogy. This is hard data plotted on the Standard Model stability diagram. This graph decides our fate. On the bottom, we have the mass of the Higgs boson, 125 GeV. On the side, we have the mass of the top quark, the heaviest subatomic particle known to science, weighing in at roughly 173 GeV. These two particles are locked in a cosmic tug-of-war. The Higgs wants to keep the field stable. The top quark wants to destabilize it. If the top quark were slightly lighter, we would be in the green zone. If the Higgs were slightly heavier, we would be in the green zone. But look where the data lands. Right here. In the yellow zone. Metastability. The universe is balancing on a knife edge between existence and erasure. The top quark is too heavy, and the Higgs is too light to stop it. The tension in the vacuum is real. We are living in a universe that is technically stable, but statistically doomed. The ball is sitting on the ledge. The wind is blowing. And gravity is waiting. So, the ball is balanced on the ledge. The true vacuum is waiting below. According to classical physics, we should be safe. To get the ball out of the dip and over the ridge, you need to push it up first. You need a massive injection of energy to lift the Higgs field over the barrier before it can fall. Without a cosmic kick, something catastrophic, we should be stuck in the false vacuum forever. But the universe doesn't play by classical rules. It plays by quantum rules. And in the quantum world, walls are not solid. They are just suggestions. This is Heisenberg's uncertainty principle. It states that you can never know the exact position and energy of a particle at the same time. Everything is fuzzy. Everything is a probability cloud. This means that a particle doesn't have to climb over a wall to get to the other side. If the wall is thin enough, and the particle waits long enough, it can simply appear on the other side. It cheats. It teleports. We call this quantum tunneling. Now, apply this to the Higgs field. There is a non-zero probability that at any second, in any random patch of empty space, the field will tunnel through the energy barrier. It doesn't need a reason. It doesn't need an asteroid impact. It just needs the dice to roll the wrong number. This event is called bubble nucleation. It starts microscopically small, 1 billion times smaller than a proton. A tiny fluctuation where the laws of physics suddenly snap into the true vacuum state. But because this new state is lower energy, it is favorable. Nature prefers it. The tiny bubble doesn't vanish. It grows. And once it starts, it cannot be stopped. Physicists try to comfort us with math. They calculate the probability of this happening naturally and tell us the odds are astronomically low. They say the expected lifespan of our metastable vacuum is 10 to the power of 100 years. They say, don't worry. The universe will probably die of heat death long before the vacuum collapses. But probability is a tricky thing. Unlikely is not the same as impossible. Winning the lottery is unlikely, yet someone wins it every week. Being struck by lightning is unlikely, yet people die from it every year. We are playing cosmic Russian roulette. The gun has 1 billion chambers. But there is a bullet in one of them. And every single second that passes, for every single cubic inch of space in the universe, the trigger is pulled again. And the scariest part? Because of the size of the cosmos, unlikely events are guaranteed to happen eventually. It could happen in 1 trillion years. Or, the quantum fluctuation could have already happened 5 minutes ago in the Alpha Centauri system. And the bubble is already on its way here. For years, the safety of our universe relied on one assumption, that the vacuum of space is clean. Physicists calculated the probability of bubble nucleation based on empty space. They said, the odds of a random quantum fluctuation triggering the decay are 1 in 10 to the power of 100. Basically, 0. But they forgot a fundamental rule of chemistry. Phase transitions are seeded by impurities. Water doesn't freeze instantly at 0 degrees unless there is a speck of dust for the ice to grab onto. Bubbles don't form in boiling water without a rough surface. So, is the universe clean? It is filled with the ultimate impurity. In 2015, a team of researchers from Durham University published a paper that should have been front-page news. They looked at Hawking radiation. Stephen Hawking taught us that black holes are not truly black. They leak energy. They evaporate. And here is the catch. As a black hole loses mass, it gets hotter. A massive black hole is cold. But a microscopic black hole? It is a furnace. The environment effectively around the event horizon of a tiny black hole reaches temperatures energetic enough to kick the Higgs field. Think of the Higgs field like a sheet of ice again. It is strong enough to hold us up. But if you drop a red-hot coin onto the ice, it doesn't matter how thick the ice is. The heat melts a hole. A decaying black hole is that red-hot coin. It creates a thermal seed. It lowers the energy barrier required for the vacuum to collapse. This means the universe doesn't need to wait for a random 1 in 10^100 chance. It just needs one black hole to get hot enough. Where are these hot black holes? They are likely everywhere. In the first fraction of a second after the Big Bang, the universe was chaotic. Some regions were so dense they collapsed instantly into primordial black holes, PBHs. These aren't the monsters at the center of galaxies. These are tiny, the size of a proton, but with the mass of a mountain. Because they are small, they are undetectable. They could be dark matter. There could be billions of them floating between the stars, completely invisible. This changes the math entirely. If primordial black holes exist, they are slowly evaporating. They are slowly ticking down to the critical mass where they become hot enough to ignite the vacuum. We are not waiting for a random roll of the dice anymore. We are waiting for a timer. The safety margin of billions of years assumed a quiet, empty universe. But in a universe filled with evaporating black holes, the odds drop from impossible to inevitability. We are walking through a minefield. We can't see the mines. And according to Hawking's math, the fuses are burning. Let's assume the worst happens. Let's assume a primordial black hole evaporates, or a quantum fluctuation rolls the wrong number. The bubble nucleates. The true vacuum is born. What does it look like? To understand the horror of vacuum decay, you have to understand the speed limit of the universe. 299,792,458 meters per second. We call this the speed of light, but that is a bad name. It should be called the speed of causality. It is the maximum speed at which any information, any cause and effect, can travel through reality. Gravity travels at this speed. Light travels at this speed. And the wall of the vacuum decay bubble travels at exactly this speed. If the sun were to explode right now, we would not know it for 8 minutes and 20 seconds. We would see the flash, feel the heat, and have 8 minutes of panic before the end. That is a tragedy. But it is a tragedy you can witness. Vacuum decay is different. Because the shockwave of the bubble is moving at the speed of light, no photon can get ahead of it to warn you. The image of the bubble is the bubble. If a bubble nucleated near the sun, it wouldn't look like an explosion. It wouldn't look like anything. You would be looking at the sky, seeing the sun as it was 8 minutes ago, completely normal. The photons hitting your retina are telling you, everything is fine. But right behind those photons, millimeters behind them, is the wall of deletion. This brings us to the most disturbing fact of all. Biology is slow. Your body is a chemical machine. It takes time for your nerves to send signals. It takes time for your brain to process reality. A nerve impulse travels at roughly 100 meters per second. Visual processing in the human brain takes roughly 13 milliseconds. That is incredibly fast for a biological creature. But compared to the speed of light, it is frozen in time. If the wall of the false vacuum hit you, it would pass through your entire body in nanoseconds. It would unmake your atoms before your eyes could send the signal to your visual cortex. It would disassemble your brain before your neurons could fire the electrical impulse that creates the concept of fear. You would not feel pain. Pain requires a nervous system to transmit a signal to a brain. Both of those things would be gone before the signal started. You would not see a flash. Seeing requires a retina to absorb light. Your retina would cease to exist. You wouldn't even know you died. One moment, you are drinking coffee, or kissing your child, or watching this video. And in the next moment, there is no next moment. There is no you to experience the end. From your perspective, the universe would never end. You would simply be paused forever in the final frame of your life. It is the ultimate silent killer, the perfect weapon. And it is heading toward us at 670 million miles per hour. We tend to think of the end of the world as a fire, an explosion, a bang. But vacuum decay is not a fire. A fire destroys a house, but it leaves the bricks. It leaves the laws of physics intact. Ash is still matter. Carbon is still carbon. Vacuum decay is different. It is not a destruction. It is a rewrite. Inside the bubble, the Higgs field has dropped to a new, lower energy state. This means the rules of the game have changed. The fundamental constants of nature, the numbers we think are written in stone, are erased and replaced with random values. The operating system of reality is uninstalled, and a new, alien operating system is installed in its place. And this new system is not compatible with us. Consider the electron. In our universe, the false vacuum, the electron is light. It dances around the nucleus of an atom, creating the shell that allows chemistry to happen. It allows atoms to bond. It allows water to be liquid. It allows your heart to beat. But the mass of the electron is determined by its interaction with the Higgs field. Inside the true vacuum, that interaction changes. The electron could suddenly become thousands of times heavier. If the electron becomes heavy, it can no longer orbit. It crashes into the nucleus. Instantaneously, every atom in your body collapses. Or, perhaps the fine structure constant changes. The electromagnetic force that holds your molecules together simply turns off. You wouldn't melt. You would dissolve into a mist of subatomic particles that can never, ever combine again. It gets worse. Some models predict that inside the true vacuum, protons themselves become unstable. The proton is the building block of all matter. It is supposed to be immortal. But in the new physics, protons could decay into positrons and pions. This means that matter itself, the very concept of stuff, becomes impossible. The bubble leaves behind a universe that is unrecognizable. No stars, no gas, no dust, just a cold, dark soup of exotic particles and radiation, governed by laws we cannot comprehend. It is a universe where life is a mathematical impossibility. And this bubble doesn't stop. Because the true vacuum has lower energy, it is better in the eyes of thermodynamics. It will expand forever. It will eat the Earth, then the solar system, then the Milky Way. It will continue expanding at the speed of light for trillions of years, erasing the history of the cosmos galaxy by galaxy. It is the ultimate eraser. Everything we have ever built, every song ever sung, every memory ever made, it won't just be destroyed. It will be rendered physically impossible. It will be as if we never existed at all. Up until now, we have talked about the vacuum decay as a natural disaster, a random act of God. But what if it isn't random? What if the trigger isn't a black hole or a quantum roll of the dice? What if the trigger is us? Before he died, Stephen Hawking left humanity with a chilling warning. In the preface to the book Starmus, he wrote about the worrisome feature of the Higgs potential. He warned that if the Higgs field were subjected to extreme energy inputs, it could undergo catastrophic vacuum decay. He said, the universe could undergo catastrophic vacuum decay, with a bubble of the true vacuum expanding at the speed of light. This could happen at any time and we wouldn't see it coming. Hawking wasn't a conspiracy theorist. He was the smartest man on Earth. And he was worried that we were playing with matches in a room full of gasoline. The Large Hadron Collider, LHC, found the Higgs boson by smashing protons together at 13 teraelectronvolts, TeV. That was enough to find the particle. But it wasn't enough to break the vacuum. But scientists are not satisfied. They want more. CERN is currently planning the Future Circular Collider, FCC. This machine will be a beast. A 100-kilometer ring buried beneath Europe. It is designed to smash particles together at 100 TeV, nearly 8 times the power of the current collider. They tell us this is necessary. They say we need to find new physics. They want to understand dark matter. But new physics is just a polite way of saying unknown physics. We are building a machine specifically designed to reach energy levels that have not existed in this part of the universe since the Big Bang. The physicists at CERN have a standard defense. They say, "Don't worry. Nature does this all the time." They point to ultra-high-energy cosmic rays, UHICers. These are particles from deep space that hit our atmosphere with energies far higher than anything the FCC can produce. They argue, if high-energy collisions could destroy the universe, these cosmic rays would have done it billions of years ago. It sounds comforting, but there is a flaw in that logic. A cosmic ray hitting the atmosphere is like a bullet hitting a wall. A particle collider is different. It is two bullets hitting each other head-on, inside a magnetically sealed vacuum, concentrated into a microscopic point. The conditions are not the same. We are creating a localized area of extreme density and temperature that does not naturally exist in our solar system. We are acting like children who found a sleeping bear. We poked it with a stick, the LHC, and it didn't wake up. So now we are building a bigger stick, the FCC. We assume the bear is dead. We assume the vacuum is stable enough to handle the stress. But remember the graph. Remember the yellow zone. We know the vacuum is metastable. We know it is fragile. Is it really wise to hit it with a hammer just to see what happens? The pursuit of knowledge is noble. But there is a line between curiosity and suicide. And when you are gambling with the existence of 2 trillion galaxies, you have to ask yourself, is finding the next particle worth risking the delete button? This brings us to the most famous question in astronomy, the Fermi paradox. Where is everyone? There are 100 billion stars in our galaxy alone. There are billions of Earth-like planets. The universe is 13.8 billion years old. Statistically, the sky should be buzzing with radio signals, trade routes, and megastructures. But when we look up, we see nothing. We see a graveyard. Scientists have proposed many great filters, obstacles that wipe out life before it can colonize the stars. They usually blame nuclear war, asteroids, or climate change. But what if the great filter isn't a disaster? What if the great filter is a physics trap? Here is the terrifying theory. Perhaps intelligence itself is self-limiting. Every advanced civilization eventually discovers quantum field theory. They eventually build particle colliders. They eventually try to unlock the secrets of the universe. It is inevitable. Curiosity is the engine of intelligence. But maybe the universe has a glass ceiling. Maybe there is a maximum energy level that a civilization is allowed to reach before they accidentally trigger a vacuum collapse. They build their version of the future circular collider. They push the energies just a little too high, looking for a theory of everything. And snap. They pop their local bubble. They don't just kill themselves, they delete their entire solar system. The reason the universe is silent is because everyone who gets smart enough to speak destroys the microphone. But, you say, we can escape. We can build starships. This leads to the cruelest irony of all, the warp drive paradox. To survive the death of a star or the expansion of the universe, a civilization needs faster-than-light (FTL) travel. The most scientifically plausible way to do this is the Alcubierre drive, warping space-time to surf a wave faster than light. But look at the physics required to build one. To warp space-time, you need to create a shell of negative energy or exotic matter with densities that rival the Big Bang. You are essentially creating a localized, high-stress distortion in the Higgs field. The very machine you build to escape the trap is the trigger. The energy density required to warp space is likely higher than the stability threshold of the vacuum. The moment you turn the key on the warp drive, you nucleate a bubble. You don't go to Alpha Centauri. You go to oblivion. This might be the ultimate cosmic joke. The universe forces you to stay in your cradle. If you try to leave, if you try to become a god, the laws of physics strike you down. We are trapped in a room with a bomb, and the only way to open the door is to detonate it. This explains the silence. The galaxy isn't empty. It is just filled with the ghosts of civilizations that tried to play God. We are currently the noisy children in the quiet library. We are building our machines. We are ramping up our energies. We are shouting into the void. And we are assuming that because we haven't been slapped yet, we never will be. But if the great filter is real, we are walking right into it with our eyes wide open. We think we see everything. We have telescopes that can see the afterglow of the Big Bang. We have mapped billions of galaxies. But there is a part of the sky we cannot see. It is called the zone of avoidance. Because we live inside a spiral galaxy, the dust and gas of our own Milky Way block our view of roughly 20% of the universe. It is our cosmic blind spot. And of course, that is exactly where the monster is hiding. Decades ago, astronomers noticed something disturbing. Everything is moving. The Milky Way, Andromeda, and thousands of other galaxies in our sector are not just drifting randomly. They are flowing. They are being dragged at 600 kilometers per second towards a single, specific point hidden deep within the zone of avoidance. We call this anomaly the Great Attractor. It is a gravitational titan. To pull us this hard from this far away, it must have the mass of tens of thousands of galaxies. Scientists assume it is just a massive supercluster of stars, the Enorma cluster. But here is the problem. When we use radio telescopes to peek through the dust, the math doesn't quite add up. The visible mass in that region doesn't seem strong enough to account for the sheer violence of the pull. So, we are left with a terrifying question. What is huge, invisible, and drags the universe towards it? There is a fringe theory in cosmology, a dark horse explanation. What if the Great Attractor isn't a cluster of matter? What if it is a vacuum bubble? If a false vacuum decay event happened billions of years ago in that direction, it would create a region of true vacuum. The physics inside that bubble would be different. The energy density would be lower. This creates a massive potential difference, a cosmic slope. Gravity and space-time itself might be sliding into the hole. The pull, we feel, isn't the gravity of a star cluster. It is the current of space-time draining into a region where reality has collapsed. We are not flying towards a city. We are circling the drain. And this leads to the final piece of evidence, dark energy. We know the expansion of the universe is accelerating. Galaxies are flying away from each other faster and faster. We don't know why. We just made up a name for it, dark energy. But what if dark energy is just a symptom? Imagine a piece of fabric stretched tight. If you burn a hole in the center, the fabric around the hole pulls back. It snaps. It accelerates outward. Some theoretical models suggest that if the universe is decaying at its edges, if bubbles are nucleating far beyond our horizon, the remaining fabric of space-time would stretch and tear to compensate. The acceleration we see isn't a mysterious force. It is the structural integrity of the cosmos failing. If this theory is true, we are already dead. The Great Attractor is the wall of the bubble, and we are moving towards it at 1.3 million miles per hour. We are worried about creating a bubble at CERN, but we might be worrying about a match while we are already standing inside the furnace. We are flowing down the river. We can hear the waterfall ahead. We can't see it because of the mist, but the current is getting faster, and there is no turning back. So, where does this leave us? We started this journey with a celebration at CERN. We ended it staring into the abyss of the Great Attractor. It is a lot to process. The human mind is not built to understand this kind of threat. We are built to fear tigers, fires, and storms, things we can see, things we can run from. We are not built to fear a math equation. But the equation is there. 125.35 GeV. That number is etched into the bedrock of reality. It tells us that our existence is a fluke. We are living in a temporary pocket of order in a chaotic universe. We are building our castles on a patch of thin ice, while the deep water waits below. Does this make everything meaningless? If the universe could delete us tomorrow without a trace, does it matter what we do today? I think it matters more. Because we are fragile, we are precious. Because we are living on the edge of a knife, every second we don't fall is a victory. Every breath you take is a defiance of the odds. We are the universe experiencing itself, holding onto the ledge for as long as we can. Maybe we will find a way to stabilize the vacuum. Maybe we will find a way to escape to a new universe. Or maybe we are just the flash of a sparkler in the dark. Right? And then gone. NASA says not to panic. They say the odds are in our favor. But remember the black holes. Remember the silence. The universe doesn't make promises. It only makes probabilities. So, tonight when you look up at the stars, don't just see them as pretty lights. See them for what they are. Survivors. Just like us.